So if we are worried about a single EC2 instance, or I can say a single server, is not enough in terms of downtime, what I can do, I can have two EC2 servers, right? I'm not saying it's the only one, but here is something that you have to maintain. So I'm taking one server, two server, let's say three server, four, and many more like this. And what we did, because there was a chance of a single server, so we are installing Docker engine everywhere. We are installing Docker engine everywhere. Okay, now you are a Docker engineer sitting here in your laptop. So you are a Docker engineer. Very good, you are a Docker engineer. Now you have so many servers, so that means even if the electricity or due to any reason this server goes off, these are still there. So let's say if I am giving a single application to you, you converted that application into Docker image. Now what you do as an administrator, you just download this image somewhere. Let's say you're deploying this Docker image to this machine and the container is running. Okay, you still have so many access of servers. If the container is running and there is no problem, what if this goes down? You can write some script or some process to take this container or take this Docker image and deploy a new container here from the same image. If this server goes down, you have a script that will keep checking it, and it will deploy or select another machine and deploy the container. You know that from a Docker image to create container, it is not taking more than 1 to 5 second time. So it's okay if it is getting down for 2 seconds as a human, right? If it is okay if it is getting down for 2 seconds or 3 seconds or so. Okay, and if something happen, it is going to, you can use this server or you can maintain that one again. So rather than dependent on a single server, you can have so many servers, and then you can keep switching your application in the next one, because you have written some script. Maybe you can use here Ansible to deploy container on the target machine. Okay, so first of all you have to learn Ansible and you have to deploy it somewhere, right? Now assume that as of now you are having only one Docker image and you are writing Ansible script for one Docker application, container. For example, let's say you have 10,000 Docker images for 10,000 different customers, and now you have to manage these 10,000 Docker images to deploy 10,000 containers across different nodes. Let's say 2,000 containers are here, 1,000 are here, 3,000 are here, and so on. So what you have to do as an engineer, because you know what, in the real world environment, if you are purchasing that much costly servers, definitely you are not going to host only a single application. You're going to host so many applications for business purpose. So 10,000 application, and some of application running here, there, and so many buzzing things are there, right? Now if 10 customers are saying their website is not working, then you have to figure out of this 10,000 which Docker image of this customer is, and you need to call your Ansible. Yes, now this customer is buzzing me. Run those 10 playbooks and check if this container is not available, deploy it somewhere else. Don't you think how the big asshole management is here, right? That means you are going to be crazy, right? because 10,000 Docker images and so many containers are running here and there, remembering them which customer website is running in which Docker engine, which one is down, just take them out and put it over there, remember that in somewhere Excel sheet and keep maintaining that, and you'll be like, shit, fucked up, oh my god, right? If you're understanding that situation, management of container is a big problem. Management of container is big problem, right? If you are understanding it very well, this situation, see, right now we have 4 servers. Let's assume it, we in real world we have 10,000 servers, we have 1,000 servers, 100 servers, and each server running 1,000 of containers. You have to remember which server running which container, and this is for which customer particularly. Okay, so type yes, okay, fine, understood message in the chat window if you are understanding it very well. Okay, I think my streaming is not down, is it? Internet is working, right? So hello, hi, okay, yes. So if you are understanding it very well, just type yes, okay, cool, fine, bingo, whatever message you want. But this is really important, that this problem is really very big. All right, great. All right, so it is really very understood, very much obvious when you have so many applications. It is really very impossible to manage and remember all those things. All right, now if I'll go back here, wonderful, if I'll go back here, so this kind of situation in the world of containerization, we need to solve it. Okay, so if we have this kind of situation in the container, so we need something that can automatically perform all these things for you without worrying about anything. It can automatically decide, okay, which customer website is not working. It will automatically solve that problem. As a human, you don't have to make an interruption over there, right? So this kind of thing, we call it, in reality we are calling it container orchestration. So that means managing those container, maintaining it, upgrading, and making database and so many things is known as container orchestration. So we need some container orchestration tool that can solve this problem for us. So these container orchestration tools are number of tools in the market. So the first one is Docker Swarm. Okay, so Docker has its own tool called Docker Swarm, and that is awesome, actually very awesome tool. Then there was one more tool that is not being used these days, Doku. You can use Apache Mesos, right, and many more, or you can use Kubernetes as well. So Docker Swarm, Doku, Apache Mesos, and Kubernetes. There is a huge list, right? Huge list. So the word most powerful and most popular container orchestration tools, or I cannot say tools, technology, right? The most popular one is Kubernetes. I can say most popular, most powerful, most amazing, you name it. Any feature in Kubernetes is the awesome product, right? So Kubernetes is the awesome product. right, ever. So actually Kubernetes is my crush. I've never seen such an interesting technology till now, and I'm in love with Kubernetes, right? So, and if you practice it for every day, you know what, you're going to love it too, definitely, right? So Kubernetes is the next generation container orchestration engine. So definitely we are going to talk about Kubernetes, and Kubernetes is also known as K8S because we have 8 characters between K and S. So Kubernetes is also known as K8S, right? So Kubernetes is the next generation, right? Next generation container orchestration engine. Container orchestration engine, right? So for Kubernetes, let's say hurrah. So you can type hurrah in the chat window just for, to show your gratitude or happiness, because we are going to learn the most amazing technology ever, that is Kubernetes, right? So I'm expecting messages from everyone, and make sure whosoever have joined today, only these people will be able to attend these sessions from now onwards, right? So I'll be making this private channel, private video. Great. So waiting for a response from everyone. Great, wonderful. I like this energy anyway. Fine. So now Kubernetes is originally, and I'm just calling it K8S for now. So K8S is originally designed by Google, right? So Kubernetes is originally designed by Google, and Google has written in Go programming language. So the most amazing example of Go product is Kubernetes. So entire Kubernetes is designed in Go language, right? And you know what, this is the most recent technology even. So I think in 2015 Kubernetes came in IT industry. I need to check it, but I guess it's 2015. So Kubernetes, yes, 2014 it was, 7 June 2014, 5 years back, right? So right, great, Piyush. So and it is written in Golang, right? Initially designed by Google. Now Google has donated this product to a company called CNCF. Now CNCF is these days maintaining Kubernetes, and it's pure open source project, right? So Cloud Native Computing Foundation is the company as of now that is maintaining Kubernetes these days, but it was originally designed by Google, right? See, originally designed by Google, but now maintained by Cloud Native Foundation, Computing Foundation. And it's just 5-year-old technology. And don't trust me, just Google it about Kubernetes. Is the most popular and amazing product ever, right? So definitely when Google has so much time, and they have contributed really very hard So for Golang developers, it's really amazing. Yeah, that has no worries. So anyway, so first of all, you have to understand how Kubernetes is going to solve this problem that we have introduced here. Okay, so first of all, you have to understand Kubernetes architecture. So first of all, we are going to talk about Kubernetes architecture. Okay, so that means Kubernetes architecture, if you understood the Kubernetes architecture, you will be actually able to understand the power of Kubernetes, how awesome and how amazing it is, right? So as of now, let's say to deploy your Kubernetes architecture in any of the environment, now it can be deployed anywhere. So first of all, you need a server, and this server cannot be anything except Linux based. So this server must be Linux based. Okay, and we need another server, another server, another server. These also must be Linux based. This machine can be Windows, but only Windows 2019 server, not accept that. So only Windows 2019 can be, we can use for our own purpose. Now everything is connected to a networking switch, so that means now this main system is connected to this networking device, and this device having connection to this. Okay, so at least this is the minimum or the most simplest thing you need to understand in Kubernetes. All right, so that means in Kubernetes architecture, this will be calling as a Kubernetes master, and these machines we are calling as Kubernetes minions. Okay, so minion 1, minion 2 and minion 3. So the main system, I mean this one, will be calling as a Kubernetes master, and these machines will be calling as Kubernetes minions. And in some cases, right, in some cases we are also calling them worker. So either you call them minion or worker, but the right or correct name is minion, right? So we have three minion: minion 1, minion 2 and minion 3, and this is my master machine, and they all are connected through networking, so they all four can communicate to each other. Now to deploy Kubernetes setup, right, what you need to do, you need to install Docker in every machine, right, here also and here also. So in master and minion both, you need to deploy what I say Kubernetes, sorry, Docker in every machine, right? So hopefully you are also understanding we need to install Docker. Why we need to install Docker, that point I'll be telling you. Okay, let me tell you, because you know what, Kubernetes can not create containers. So Kubernetes is not for creating containers, Kubernetes is for managing containers. So if you see here on the above, this is orchestration tool, container orchestration tool, and here Docker has created those containers. So the container created by Docker or any other product, it will be managed by Kubernetes. So that's why we need Docker everywhere. Or If not Docker, any container technology, let's say we can also use Podman, we can also use Cryo, whatever technology, container D, and many more. So I hope if you are understanding it, we don't need only Docker, any product like Docker, Podman, something. So say yes in the chat window if you are understanding. Kubernetes is not for creating containers. Kubernetes is for maintaining containers, managing, auto-scaling, security, and a lot of things. So that's why we need Docker everywhere, or any of the container runtime technology. So if you are understanding it, just say yes in the chat window. All set. Wonderful.